The following is the video solution from JSDT Solutions. Question 8.1.1, we have to derive this. Now, do you see what is inside here doesn't really need to be prepared to be derived. We don't have any x in the denominator or any surds, so we can straight away start deriving. So this is equal to, remember it's coefficient times exponent, so that's 3x. And what happens to this x is it has an exponent of 1, but you subtract 1 from the exponent, leaving you with a 0. Anything to the power of 0 is 1, and 3 times 1 just stays 3. Same thing happens here. So we have negative 10x, and of course we have an exponent of 1 left, but we don't have to rewrite it. So this is our answer. Question 8.1.2 says we have to find g prime of x if we are given that g of x is equal to this. So do you see here with this one, you have x in the denominator, you have a surd. Clearly there are things that we need to fix here. So we'll say g of x is equal to, and to sort this out, to make sure that this is not in the denominator, we'll bring it to the numerator. So the 2 stays there because there's nothing wrong with it. And x comes to the numerator, but the exponent will become negative because of this. And then we have minus, and we can rewrite this as x. And instead of leaving this as a surd, we will take the inside exponent and we'll put it over the outside exponent. So that's going to be 7 over 3. And now we are ready to derive. So g prime of x is equal to coefficient times exponent is negative 4x, exponent minus 1, negative 3. Again, coefficient times exponent, negative 7 over 3x, exponent minus 1. So you see that's 7 over 3. If you minus by 1, you can just say it's minus 3 over 3. Or use a calculator. Okay, that's fine. So that is 4 over 3. And this is our answer. Question 8.2 says, determine the equation of the tangent to f of x. As we can see, f of x is a cubic function, and we're trying to find the equation of the tangent to this function at x equals 2. Okay, so here is a representation of what's going on. You see, this is a cubic function that sort of looks like an n, because you can see that the value of a is greater than 0. So it looks like an n, just more curved. And so what is going on is that you have this, and then you have a tangent at x equals 2. So wherever that is, you can just put it anywhere for now. Let's say it was here, okay? So let's say it looked like that. And so that is x is equal to 2. How do we find the equation of the tangent? Because that's the main goal. Find the equation of that tangent. Well, a tangent is a straight line. And so the equation of a straight line is y equals mx plus c. But the thing is, we need m, and then we need another point. So how do we find the gradient of this function, m? We'll find that gradient using the cubic function. So what we know about this point is that the gradient of the tangent and the gradient of the cubic function at this particular point are exactly the same. So that's what we're going to do. We're going to use that theory to find this. So to find the gradient of the cubic function, you would derive it. So f prime of x is equal to, and this will be 3x squared minus 8x plus 2. Okay, now we're specifically saying it's the gradient of the cubic function at this point where x is equal to 2. So to find that gradient, we have to substitute 2 into the gradient formula. So that is 2 is equal to, and when we substitute 2, we'll find out exactly what that is. And we get this gradient is negative 2. So it means that the gradient of our tangent that we're looking for is negative 2. Great. Okay, so we were able to find the gradient of the tangent. And now what do we need? We have gradient, we need c. In order to find c, you just need 1 point on this graph. Okay, specifically on the tangent. Now you see that the tangent has a point here, but we only know that this point's x value is 2. How would we find the y value? We find the y value because it is also on the graph of f. So let's go ahead and substitute that point 2 into the original equation, and we would find out what the y value is. And we see that the y value when x is equal to 2 is negative 1. So we have a point, 2 and negative 1. Okay, so let's go ahead and use that. So we can just go ahead and use y equals mx plus c for this. we already have m as -2, so -2x plus c, and then we're substituting. So -1 is equal to -2 times 2 plus c, and therefore c would be equal to, you can just multiply here, that gives you -4. When you take it over, it becomes +4, so that's 4 minus 1, which is 3. And so this means that the equation of your tangent is y equals -2x plus 3. And that is our answer. 8.3, given f of x is equal to -6x squared. 8.3.1 says determine f prime of x from first principles. Okay, so we can first focus on finding f of x plus h. So we can just substitute it. So wherever you see x, replace it with x plus h. So this is -6, and in place of x, we say x plus h all squared is equal to, and then this just simplifies to, we have -6 here, and when we distribute that, that's going to be x squared plus 2xh plus h squared. Okay, and then distribute. So -6x squared minus 12xh minus 6h squared. Okay, and now we can put down our formula. So f prime of x is equal to, so now this is equal to, and we're going to just substitute. So the limit as h approaches 0, and then we take all of that and we substitute it in place of f of x plus h. And then we are subtracting by f of x, which is -6x squared. But you see, you'll say minus -6x squared. And so that ends up becoming a plus. So we can say plus 6x squared all over h. Okay, so immediately whatever you were subtracting by is what will cancel. So these two cancel, and we can just rewrite what we're left with. So this is the limit as h approaches 0, and we have -12xh minus 6h squared all over h. And now we can finally take out a common factor. And remember, the whole goal is so that we can substitute 0. But the thing is, if you substitute 0 right now, your denominator will be 0. So we want to avoid that. So the limit as h approaches 0, and then we'll take h out as a common factor. In the first term, what will be left? That will be -12x. And in the second term, you'll be left with -6h. Okay, and this goes all over h. Then these cancel because they divide and give you 1. And now you can substitute. So we're saying f prime of x is finally equal to, and you're saying -x, and then -6 in place of h, we put 0. And therefore, this means that f prime of x is therefore equal to -12x. And that is our answer. Question 8.3.2 says, write down how you will restrict the domain of f such that the inverse of f is a function. Okay, so remember that f is a parabola. It is -x squared. So it looks something like this. For you to restrict it so that its inverse is a function, you'd have to understand what the inverse would look like. So this function looks like this. It's inverse because it is sloping downwards, looking at it from the y-axis. You see that it is facing more towards the negative part of the y-axis. What the inverse will end up looking like would be something like this. So here is your graph. The inverse is going to do whatever your graph is doing, but it's going to do that on the other axis. So if it's facing downwards towards the negative part of the y-axis, the inverse is going to face towards the negative part of the x-axis. So it's going to do that. It's going to look something like this, and the graph will look like that. Now, you see how that is a problem now? This is no longer a function because it will not pass the vertical line test. It's not a function. Do you see how it cuts the graph at two places? It has two different y values for one particular x value. That is not a function. Okay, so we can make it a function by cutting off a wing, okay, and that is really called restricting the domain. So you can restrict the domain by cutting off one wing, and you have to do that from the original. So you have to choose which one you want to stay. The two wings that you have is this part, and what that part says is this is where x is, as you can see, starts from 0, is less than or equal to 0. Or you could choose to cut off this wing, which is where x is greater than or equal to 0. So any of these would work. If you restrict it using this or this, it's perfectly fine. And then that will have an effect on the inverse. So with this one, the part that will stay in the inverse would be, because it's positive in the x-axis, negative in the y-axis, the part that will stay will be positive in the y-axis and negative in the x-axis. So it'll be this wing. And then, of course, the other one, this one would stay because they're both negative in the x-axis and negative in the y-axis. So that would stay. Okay, so you can use this or this, and that will be perfectly fine. So you can give them any of these answers, and that will be fine. Okay, moving on to the next question. Question 8.3.3 says, determine the equation of the inverse for where the y values of the inverse are less than or equal to 0. So this is where y on the inverse is less than or equal to 0. Write your answer in the form of y equals. Okay, so the main thing they want you to find is the equation of the inverse. So let's take our original equation. We can just say y equals, remember it was negative 6x squared. So to find the inverse, step 1, swap x and y. So this now becomes x equals negative 6y squared. And then make y the subject. That's step 2. So to make y the subject here, you see we have y squared. So negative 6 needs to leave. So you can divide both hand sides by negative 6. And now we're going to have, and I'll just rewrite it here. So y squared equals x over negative 6, but you can rewrite it like this. You see there's an invisible 1 in front of the x. So it's actually 1 over 6 and they're negative, okay? And then you can say x. And now to get rid of the squared, we would square root both hand sides. But you have to keep in mind that this is an equation. So when you square root both hand sides, you need to consider the positive and negative solution. And this is where we need to decide. Do you see that they say the y values need to be negative? They need to be less than or equal to 0. So we're simply going to say y is equal to, and we won't take the positive solutions, we'll take the negative ones. That will be negative square root of negative 1 over 6x. Okay, and that will be our answer. And you may be looking at this and think, how would we ever get answers? Because this is negative. Well, you will, as long as x is negative, because you'll have a negative times a negative, which is a positive, and so you will not end up with non-real values. Okay, so that is our answer for this question.